All right, here we go. Congruence with multiple sides. So we're going to talk about three-sided figures. This is going to be called side, side, side. So basically, I can say that two triangles are exactly the same if all three of their sides have the exact same measures. So I'm going to call this a 3, 4, 5. I'm going to label it A, B, C, D. I'm going to label that A as the right part of that. A, B, C, D. My 5s have a 90-ish degree angle here. They do not look like S's. So, if you're not going to remember this, if you're going to think it's 5, 5, 5, maybe you should write side, side, side. Alright, anyway, side, side, side is the first one that you're going to learn. It's a postulate. If three sides of one triangle are congruent to three sides of another triangle, then these two triangles are congruent. So I'm going to create another triangle over here. I'm just going to kind of mirror it the best that I can. If I could draw a pretty triangle, that would be wonderful. Goodness. Okay, so I'm not a great kind of artist here. But let's pretend that this is a right triangle and that this is 3, this is 4, and this is 5. I'm going to name these D, E, F. D is going to be my right angle. So, since it has 3 congruent sides, here, here, and here, then I know that these two triangles are congruent. And I can write them congruent like this. I will put a triangle, and you will probably see me bold mine in. I don't really know why I do that, but I do. Anyway, triangle A, B, C is congruent to triangle, and then I want you to pay very, very good attention, so get caught up if you're still writing stuff down. Okay, if I'm labeling these triangles congruent, I will have an ability to write a congruency statement from these. Meaning, if I put these in the right order, then I know a lot of things about a triangle. So watch. A, B, C. A, B, C. I want to put these in the same order over here. So if AB is the length 4, then I must go DF when I label this one, because they are the same length. So AB and DF are both 4. And then I'm going to look at the next one. BC. BC is the 5. FE is the 5 on that one. So I'm going to put them together. And then CA is 3. CA. And then ED. ED is 3 on the last one. So just by writing them in the correct order, I am able to tell you, even if I didn't have the drawing, if I was covering that up, if I didn't have the drawing, I would be able to still illustrate with confidence that segment AB is congruent to segment DF. Also, that segment BC is congruent to segment FE. And then lastly, that segment CA is congruent to segment ED. But there's another thing that can be said about congruent triangles. Their corresponding angles are also congruent. So, A is congruent to D. Angle A is congruent to angle D. Angle B is congruent to angle F. And angle C is congruent to angle E. Okay? So I can tell all of that without this picture now, because I wrote my congruency statement properly. Okay? So it is very, 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 very important that you put them in order. Otherwise, you're going to give basically the wrong information. So be careful when you're doing that. Any questions about it? Anybody still need this up?
Yes.
Okay. going to come over here and I'm just going to draw a couple of triangles. They're probably not going to be exactly the same, but I'm going to try to make them as close as I can. If these are indicated with tick marks, okay, I can still say that they are equal to each other, okay? Those triangles? These ones right here?
Yes. I'm actually trying to do my notes today.
I'm so proud of you.
I'm going to be good listening to do my lessons.
Alright, so looking at this picture, I can still write the congruency statement right there. So I'd say triangle, and then I just name the first one, ABC, is congruent to, and then I'm going to look. AB was actually EF, so triangle EFG. Okay. And then I'd be able to list all the things like I did here underneath that if I needed to. Okay? So be careful when they ask you for certain things. Alright, next one. This one's going to be side angle side. So basically, you have to find a side congruent to another side, an angle that is in between, and then another side. Okay, so if I draw this one, tick mark, arc mark, double tick mark. If I'm going to prove this one congruent to another one, okay, so I would need the same exact information. I would need to know that this side is congruent to that side. So let's say that that was 3. This angle, 120, is congruent to this angle, 120, and that this last side is also congruent to this last side. And they'd have to be in that order, okay? I can't say two sides, okay? I'm going to show you an example here in a second. I can't say this side, this angle, and that side, okay? They have to be in order. I have to follow them around. In other words, it has to be an angle in between the other two sides. Okay? This side and this side would work if we were knowing this angle, not this one. Okay? So this does not work. There is no side-side angle. Mainly because if you flip it around, it makes a very bad word. Alright, flip your page if you have not done so already. We are going to use this coordinate plane that is located right there on the next page. Alright, see if we can get it. Coordinate plane at the right shows triangle ABC and DEF. Use side angle side postulate to prove that these two triangles are congruent. Then identify the rigid motions that could transform them. So remember, rigid motions were our rotations, our translations, our reflections, etc. Okay, so first of all, we need to find out the sides. If there's an angle, the angle, and the other side. Using side angle side, BA is congruent to what side over here? DE. It's the same on yours as it is on mine. Then angle A is congruent to what angle? And what are their measures? How do I know that? Because they're directly on those lines. That's really the only reason. And AC is congruent to DF. Alright. Uh-oh.
You said DC.
Did I?
No, you said AC.
Oh, okay. AC is congruent to DF. Just in case I said it wrong. AC is congruent to DF. Alright, so if I'm doing this example, this is exactly how I would do it. Okay? I would list the things that I know. Okay? We know, and we identified that AB was a segment, right? And it was congruent to DE. Whoops, DE. Segment, DE. And if I actually read how long those were, it was 3 units. Okay? Then the other one that we knew, it was AC is congruent to DF. Thank you. And that, if you actually counted it, was 1, 2, 3, 4, 5? Levi, was it 5?
Yeah.
You sure? I think it might be 6.
No, I heard you say 5.
Oh, okay. Just wondering if you counted it with me or not. Okay, so I can tell these by just looking at them, right? So I already have a side and a side, and I also said the angle A was congruent to angle D, and that they were both equal to 90 degrees. Fahrenheit or Celsius, Levi?
Money?
No, it's not money. Just degrees is fine. So, I have a side, I have an angle, and I have a side, and they're in order when you look at them. So, I can prove these two triangles congruent by side, angle, side, and I just need to state their given order. So, obviously ABC was the first triangle. I'm going to mark it down. ABC is congruent to triangle, and then I need to look at it. So if I'm going ABC, I'm going to look at it just a little bit closer. AB, DE, and then C, right? So am I going to go DEF? Yeah or no? ABC, do I go DEF? Is AB and DE congruent?
Yes.
Yes, that's what we stated, right? So AB and DE are congruent. I can look at this without even having to look at my picture. And then the next one was BC and what? BC.
Yeah.
BC and EF, right? So now I have triangle ABC is congruent to triangle DEF.
If you put like EF is congruent to CD. I hate to say it, but it's the whole triangle.
We're looking specifically at this one, but if you were just specifically stating that
On the lines, what if you
BC is equal to EF, that is the same as EF being equal to BC. That's what you asked, right?
You said CD. You said BC.
That would be wrong because AB, that would be AC.
You're talking about just this statement though, right, Tegan?
Yeah.
Yeah, that's fine. If you're just saying that statement, that's fine. But in the order for the triangles, it matters. If you're just naming the segment, it doesn't matter the order. So I could say DF or FD, it doesn't matter. Doesn't make a difference. Cool? Levi?
What? I put it up there.
Oh,
I put Tegan on side of it.
that's nice.
Like both? Yeah.
Okay, here we go. Next one.
Yeah, I'll put it on second.
Next one, flip the page. Oh, hold on. Interesting side note. We need to talk about how we rotated it, right? How we found this. What translation happened. Was it rotated? Was it reflected? What happened to it?
Holy crap, that thing was there.
She said it was reflected and translated. What?
3, no, 2 down.
If it was reflected, then it was just moved across the x-axis to the left.
Okay.
It was rotated,
So-
it was moved to the right a little bit.
I'm hearing what
and back to the left.
Sadie's right.
I'm hearing what Sadie's saying, and she's correct. She said that the x-axis was the axis of symmetry. It's where it was reflected across. She said ABC was reflected across what axis, Levi?
On the x-axis.
On the x-axis, and then translated what direction?
To the left.
How many units?
Is that box to the left?
Everything you own in the box to the left, how many units?
3.
3? Did you count them? 1, 2, 3. Yeah, you're right.
I have not been writing it like that. I've been writing it, I rotated it around point, whatever, and moved it down.
Is there a rotation that would get you there?
Yes.
Yeah.
What is the rotation that would get you?
You have to rotate, you have to rotate at point A.
And
You have to rotate what?
Point A.
Point A.
Yeah, so you can get B down. See what I'm saying?
Yeah, I see what you're saying, but how much am I rotating it?
You'd have to rotate it like, well, 90 degrees, wouldn't it? No, 270.
If I move it 270, am I going about the origin or am I going about A?
A.
Moving it about A. So if I went from here, I'd rotate it 270 degrees, so this one would go to here, then to here, then to here. So B would now be located over here. I don't think that helps you. I think you have to have a reflection in order to recreate D.
Oh, you do?
You would have
So
to.
where did you say across the x-axis?
I would say reflected across the x-axis, then translated 3 units to the left. In words, that's what I would say, literally. And I would begin with a capital letter and end with a period. Okay, next thing. Flip it. Bada bing, bada boom. This next one is angle, side, angle. Angle.
Did you use angle side side?
I just discussed that that one was not a thing due to its bad wordness. Angle, side, angle. Alright, so angle, side, angle says the same thing. We're going to sandwich one side in between two angles, and we'll use that to create a congruent dill. So, if this were my triangle, I have an angle, okay, I have an angle, I have a side, and then I have another angle. If I can, ooh, my paper moved. If I can create another one of these triangles, hopefully, with decent amount of artistability, then I can say that the two are congruent using angle, side, angle. Now, if the picture was like this, and all I knew was this side, this angle, and this angle, then I can't say that it's congruent to anything using angle, side, angle, because all I have is a side, an angle, and an angle. And right now, we don't use angle, angle, side for anything. Okay? Any questions? Sorry, you can't really see that in the picture. It looks a lot better down here. That's 20 degrees is what that mark is.
Now go straight to your lesson.
And Levi says, go straight to your lesson. And I say no.
There's like 10,000 examples.
There are a bunch. So if I'm going to recreate, go ahead and draw one out. If I'm going to recreate one of mine based off of the information given off of an angle, a side, and an angle, let's say that we have angle A equal to 30 degrees, angle B equal to 60 degrees, and we have a side, AB, that is 2 in length, 2 centimeters short. I can create that using my handy dandy whatchamajig right here. So, first of all, I'm going to create AB. AB is 2 centimeters long. Right, Levi?
Yeah, definitely.
How long?
That long it would be
How long was it?
2 centimeters.
Good job.
We need to get one ourselves.
No, don't worry about it. Okay, I just want to show you that no matter how many ways that I make this, it will always show up to be the correct length. So now I'm going to measure out 30 degrees here. I think I got that upside down, I do. I'm going to measure out 30 degrees. Alright, so if this is my 30-degree angle, you'll notice that if I create this, it's going to only intersect at one point. So I have a 30, and I'm going to have a 60 as well. It'll only cross at one place. There's no other way to draw this. So if I did it again, I did follow those exact same steps and recreated a 2 centimeter thing, then it would show up to be the exact same shape as the last one that I created? Yeah, maybe it would. You can take my word for it, or you can, do it on yourself. It's fine.
Well, I know sometimes just like that's
Yeah, it's a lot of fun. Okay, I'm just showing you that. Alright, so I created two triangles following those directions right there, just to show you that I didn't just accidentally make them the exact same length. I'm going to actually measure them out. Okay, so I'm measuring the shorter side, it is 1. Over here, it is 1. The longer leg is close to 2, and the longer leg there is close to 2. So, it's about 1.8. 1.8. So, anyways, the point is that they can create the exact same thing. Okay, showing you, proving it to you. So if they ask you to make one of those, you just follow the steps, you make those angles, and you might need a protractor to do that. Use the ones that are over there. Okay, here we go. Here's our problem. It says triangles PQR and STU are shown in the coordinate plane. They are shown on that page if you have not flicked there already. It is given that angle P and S are congruent. Angle R and U are congruent. It says prove that these two triangles are congruent. Then identify the ridge in motion that makes them congruent. So, going back to the directions. Ooh, that's blurry as all get out. P, I'm going to touch them as I identify them. P and S are congruent. P and S are congruent. And then we also know that R and U are congruent. And we're going to use one of the three theorems that we just wrote down. We have either side, side, side. We have side, angle, side. And then we have angle, side, angle. There's already a pretty good winner for which one we're probably going to use. It gave us two sets of angles. So, which one has two sets of angles? Angle, side, angle. So that one's almost a guaranteed win. Let's see if we can do it using angle, side, angle. So, we talked about the two angles being P, R. So let's look at PR. PR, oh, handy dandy. That is on a straight line, so let's count them. 1, 2, 3, 4, 5. PR is 5. And it said that P and S, I think, were congruent, R and U. So let's look and see. Look at that. U and S is nice on a handy dandy straight line here. 1, 2, 3, 4, 5. So PR and US are congruent to each other. So PR is congruent to US. And the rest was already given to us. It told us what angles were congruent. Okay? So since that was already given to us, all we need to say is by angle, side, angle, they are congruent. Okay? So after I show this, because they're both equal to 5 units, then all I have to do is say by angle, side, angle. So, the included side, that's the word I was looking for earlier. The included side. So when I say the words included side, I'm talking this angle and this angle. The included side is US. If I talk this angle and this angle, the included side is PR. It's just the side in between them, okay? So when you see that word, included side, that's what it means.